This is Mrs. Mahoney's podcast. This is our third one in Unit 8. We're at the top of page 9, and we're going to be talking about, it's again just another application and use with limiting stoichiometry. This time, instead of doing it afterwards like we did with percent yield, this is something we have to kind of do a little bit of looking at it before it. So some vocab, top of page 9. You need to know this vocab. This is where things that show up definitely as definitions. So that first one is limiting reactant. The nice thing is you've probably seen this already twice in the lab, as long as you've done both labs. The first time we looked at it, we said, okay, when that copper chloride ran out, what happened to the reaction? It stopped. So that's the limiting reaction. That's what happens. When it's gone, the reaction stops. So therefore, it limits the amount of product. Okay. So the other one should make sense. The other reactant is going to be the one you have too much of. There's really not going to be a time that you're going to have perfect amounts of both. Typically in real life, you're going to have more of one than the other. So then the excess is just what it sounds like, what you have left over. That's a straight line. It's going to be what you have left over. Okay, one key thing I saw in the lab kind of bugged me. Which side of the equation is reactants? So remember, reactants becoming products. So if I'm looking at a limiting reactant or the excess reactant, I'm only looking at the left side of the equation. I'm not talking about a product like percent yield. We're focusing this time on the left-hand side. It's a reactant. That should help narrow your focus when we're looking at some of those questions. Okay, easiest way, let's just jump in and let's kind of look at what we mean. Let's go back to that hamburger analogy again. So again, hope you've eaten. What I want to look at, this is that same basic recipe that I had before for that bacon double cheeseburger. Okay, this time, let's look at down here. Somebody went shopping, I don't know, probably my son. If I had 5 hamburger buns, 10 hamburger patties, 10 slices of cheese, and 12 slices of bacon, how many full hamburgers? I can't change this recipe. Well, let's look at this. If I have 5 hamburger patties, I could make, 5 hamburger buns, I should be able to make from this 5 hamburgers. Okay, cool. If I have 10 hamburger patties, how many should I have to make? Okay, cool. I have enough for also 5 hamburgers. Okay, 10 slices of cheese, again, 5. Okay, I have 12 slices of bacon. Well, if I have 12 slices of bacon, each hamburger wants 4 slices of bacon. Guess what? I had it backwards. This is why we write our words. In one bacon double cheeseburger, this is only enough to make 3 bacon double cheeseburgers. So look at, I'm going to run out. And unless anybody wants a hamburger without bacon, which we're not making, because we'd have too much complaints, I'm limited right there by my bacon. I'm going to run out of the bacon. I don't care if I have excess, so I have excess of the other. I would say bacon is my limiting reactant. Therefore, I can only make 3 complete hamburgers. We're going to be doing the same thing. From our reactants, how much can I make of each product? Compare whichever one makes the least. That's how I know I'm going to have my limiting. Okay, so let's just kind of jump in and read these questions, and let's really look at how am I going to know it's a limiting reactant problem, because I know a lot of times you're looking now and go, okay, I just have regular stoichiometry, now I have a percent yield, and now we're throwing something else. How am I going to know what I need to do at each equation? So let's just kind of read through this problem, and we'll look at that, how I know. So if I'm just reading through this, first thing I notice, I have 6 moles of barium chloride. Okay, I like when I give numbers. I know that that's going to mean something. But look what else. Are placed in 5 moles of sulfuric acid. What I see here is they give me 2 amounts of my reactants. That is a key way for me to realize this is a limiting reactant problem. When they give you 2 reactants, that's ding, 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 limiting reactant problems. I need to figure out which one am I going to run out of first. Okay, let's keep reading this so I can know where I'm going to have to finish. How many moles, okay, yay, we're going to go moles, of precipitate will precipitate. Okay, notice how I said that different, precipitate will precipitate. They look the same. I know that they mean differently, but still, what does this mean again? Precipitate will precipitate. What is this word? Precipitation falls out of the sky, a solid falls out of solution. This has shown up more than once. More than once, it's going to show up again and again and again. Do I need to know this word? Yes. Okay, so that means I'm going to have to use my solubility rules when I balance my equation and look at my equation. So what does it want to know? Also, how many moles of excess, okay, that's new, we'll talk about that, reactant remain after completion. Okay, let's go back to what I know. First thing, what do? Balance your equation. So go through 2 chlorines, 2 hydrogens. I'm going to have to put a 2 there. Okay, second thing I know I have to get, let's look at the precipitate. Okay, using your solubility rules, a sulfate is normally aqueous unless it's with a barium. It's over on your exception side, so that means it's not aqueous. That means we make a mistake, it's a solid. That means my hydrochloric is aqueous. Okay, so same thing, that doesn't change. You've got to balance it, you have to look at that. Where does it change is having both of these amounts, and how do I know what my answer is? Okay, up at the top I gave you some rules, steps of how we were going to kind of go through it, and I'll be honest, that's the second way I want to show you. So I'm going to go on what I think is probably the easiest to see first. I'm not saying it's always the quickest, but I think it's the easiest to recognize first, and then on Monday I'll show you the other way, and then if you like that method, then you can use that method. If you like the first way we showed, then you can use that way. Options are good. So for right now then, let's just kind of cancel that out right now and don't worry about that for right now. Well, I guess I will need this answer. But what I just need to know, don't worry so much about given and reacted. I'll come back and we'll kind of look at that. So to work it out then, the 2 ways, let's just solve both answers. What I tend to do is I just kind of list, okay, I need to keep myself straight. I'm going to do 2 things. First, I'm going to do my barium chloride, then I'm going to use my sulfuric acid. So it's the normal, okay? If I have 6 moles of barium chloride, where am I going? Barium sulfate. How do I get there? It's moles. So looking at my balanced equation, I know for every 1 mole of barium sulfate, I need 1 mole of barium chloride. So if I reacted all of that, I would get 6 moles of barium sulfate. Okay, just do the same thing now with your sulfuric. So what do I know? This time I have 5 moles of my sulfuric acid. Look at your mole ratio. I know for every 1 mole of your barium sulfate, you need 1 mole sulfuric acid. So I can only get 5 moles of your barium sulfate. So this is saying, okay, what do I have? I know that I only have enough sulfuric acid to make 5 moles of barium sulfate. Okay, I do not have enough to make this. So this means, and right here, this is telling me I'm going to run out of this first. This is my limiting reactant. Because I run out of it first, I can make the least amount of product. That's my limiting reactant. So therefore, if that's my limiting, that means I'm going to have excess of your barium chloride. It's going to be left over. Kind of like the aluminum when we did that. You had a big chunk of aluminum left over. You ran out of your copper chloride. So when you look and say, dang, I just did double work. No, you didn't, because it asked you what is your answer. Here's my answer. So you just did your work to find your answer. So this really tells you what my limiting is, and it tells your excess, and you just solved your problem. So don't think of it like you're doing more work. It's just the way to reach a couple questions doing it. Okay, that answered this question. So then let's look at this, because I ask this sometimes too. Okay, great, I reacted that, but how much do I have left over of my other reactant? So if I know sulfuric acid is my limiting, I need to now do one more step to say, okay, how much barium chloride did it take to react? Now, I know probably a lot of you are looking at this and can see this clearly. Hopefully a lot of you can see this clearly, because when I say this, look at this. It's a 1-to-1. I need equal amounts. So if I have 5 moles of this, I'm going to need 5 moles of this. That's what I'm looking at. Okay, but I'm going to show the math because it's not always something that you can look at and see right away. So that's why I show the steps. So if you can see it on the easy ones and it makes sense, maybe we can transfer the ones that are a little bit more. So what I need to know is how much of that barium chloride will it take? Well, what we just said, for every 1 mole of barium chloride, you will need 1 mole of sulfuric acid. My pen's being weird. So yes, we are right. What we saw in our head, I do need 5 moles of your barium chloride. Okay, this is again where our part of this on limiting reactants, you really have to use kind of some common sense. And so what is this telling me? This is telling me this is how much reacted. Okay, go back. How much did I have? I had 6 moles. Okay, so we can figure this out. I had 6 moles. I used 5 moles. Therefore, I have 1 mole in excess. And what is it? It is barium sulfate. Pen's being weird. So this is my excess. Will I ask this every single time? No. When do I have to do this? When it asks for excess. These are more involved. I will say that. Are you going to have 10 of these on a test? Nope. But will you have one? Yep. So let's just kind of look at some more. Okay, again, look at, I'm keeping to moles. Okay, going through, what is it asking? Okay, identify the limiting reactant and the moles of excess. Dang it, I sure like when they don't do that, but we can do this. Moles of excess reactant remain after the reaction is completed. Okay, notice this time it didn't really even ask me how much product, but you know what? We're going to do it anyway because I'll be honest, there's not going to be very many times I'm just going to ask you about excess. You're going to be asked about product, so let's just go ahead and do that too. Okay, but look at what I was given. 3 moles of aluminum, 3 moles of oxygen. It looks like I have equal amounts. You're going, cool. Well, I can do that. No problem. They're going to be the same. I'm not going to run out of any. No, that's not going to happen because we need to go back and look at our balanced equation. Again, how do I know this is limiting reactant? Look at, you have each. Go back, balance your equation. So I put a 2 there, 4 there, 3. This is where it's different. Because if I look at this, what do I know? I know that I'm going to run out. I need more aluminum, I need more aluminum than oxygen. I need more aluminum than oxygen. I know kind of from this, I'm going to guess that I'm going to run out of aluminum, but we can't just guess. You can't just put that on a paper and say on a test. I need to prove it. So let's look at how much I will get. Well, I'll get 2 moles of aluminum oxide, and again, I'm just going to each product, to 4 moles of aluminum. So how much will I get if I do that? I know I put this on somewhere. I will get out 2 moles. Sorry, I did it different ways on that. Mrs. Fisher's here and she's helping me as I go through. It's also really, really intimidating making this in front of somebody. Okay, oops, sorry, 1.5 moles. You know what, I could do that in my head. What is 6 divided by 4? 6 divided by 4 is not 2, it is 1.5. I get, after you guys, I need to do my same thing. Okay, what if I had my oxygen? So for every 3 moles of oxygen, let's look at this, I get 2 moles of aluminum oxide for every 3 moles of oxygen. Okay, now this one I really can do in my head because my 3's cancel. And I would get my 2 moles of aluminum oxide. Okay, we were right. Look it, I cannot make enough of, I make the least amount of aluminum oxide from my aluminum. So what does this tell me? When it says identify my limiting reactant, aluminum, this is my limiting reactant. Therefore, I'm going to have excess oxygen. Okay, this is my excess. But then it did ask, okay, how much excess do you have? Well, let's look at how much oxygen I used, because I can't know how much excess until I know how much I used. So to go to oxygen, I know I'm going to need 3 moles of oxygen for every 4 moles of aluminum. So when I look at that, I know I'm going to use up 2.25 moles of oxygen. So this is how much was used. This is what you just calculated. So for every 3 moles of aluminum, I'm going to use 2.25 moles of oxygen. So let's kind of go back up to this then. How much did I have? Well, I started with 3 moles of oxygen. I used 2.25 moles. Therefore, I have 0.75 moles of oxygen excess. You've got to look at the whole process. How much do I have? How much did I use up? Okay, let's turn the page. Let's do a couple more that maybe, are they always going to be moles? So what I'm going to do, I'm going to skip this one. This one is just a mole to mole. I think some of you I want you to try this though. This one is for you. Say this is yours. And if you notice when we do a packet check and looking at that, this is what we're checking. Did you go beyond? Did you finish the ones that I asked you to finish? I've done 2 mole to mole. I want to step it up. So let's look at the next one, because look at, I'm not asking for mole, I want to know grams. I did give us moles, but I still want to go to mass. And if I'm looking at this, let's one at a time find the mass of the product in the synthesis reaction. Okay, give me 2 amounts. I have iron and I have oxygen. Again, that's what tells me it's a limiting reactant problem. Then it tells me find the mass of the excess reactant. Okay, take one thing at a time, one problem at a time. Let's start with this. First step, what do we always have to do? Balance your equation. So I know I have 2, that gives me 4 moles of iron, and I'll need to have 3 moles of the oxygen. So I want to find the mass of the product. Let's just react them both out. How much can I make from iron? How much can I make from that oxygen? I add this, you think it's extra steps? Maybe it is, but what it does is help me to get organized, because if you notice this, I'm going to have stuff written all over the place, and if I don't write and label down my answers, and right there, and if I don't label my answers, I get myself confused. Like I just did there, go back, double check. Is that what I was given? And what else do I know in oxygen? I have 6 moles of oxygen. Okay, one at a time. Let's figure out how much product I can get. So I'm going to 2 moles of my iron oxide for every 4 moles of iron. And then let's just go ahead and figure out how much product I can get. So I know the moles of F2O3. That means up here I am going to need this molar mass. So 2 times iron plus 3 times oxygen, and the molar mass is 159.6. Now again with the significant figures, if I have a decimal in the middle, I don't round it. I leave it. 0.9s, 0.9s, 0.01s, those are the ones I go ahead and round to the whole number. But when my decimal, when I'm rounding too far, I don't like that source of error. That's when I go ahead and make sure I put the 4 significant figures. Okay, so then when I write that out, my final answer up here, this would say that I'm going to make 399 grams of my iron oxide. So if I have 5 moles of iron, I can make this much iron oxide. Well, let's compare it. If I have 6 moles of oxygen, how much iron oxide can I make? So this time it's 2 moles of iron oxide for every 3 moles of oxygen. Same thing. Let's go. Oh, this is nice. This is where it's nice, because you think you're doing double work, but you know what? You've already figured out that molar mass once. You're just doing the same molar mass because you're going to the same products. This should have a gram up there. Further to cancel. No, excuse me. Oh, I just got these backwards. Dang. I'm tired. I need another coffee. Did you guys see what I did? I think Mrs. Fisher did. She was giving me the high sign over here. No wonder. That was a flip board. She was trying to let me know I got it flipped. Hopefully all of you are going, Mrs. Mahoney, you got it flipped. Because I'm not going to cut and redo this. So guess what? You guys were all right. I've got it flipped. This is why you show that. Because when I put my grams, like, ah, dang. But you know what? You know what I meant. So let's go this. See? Nobody's perfect. Believe me, I am the last person to say that I am perfect. Mistakes are made, but you know what? I caught it. That's the difference. Catch your mistake, go back so you know what you're doing. That's the important thing. This is why we use pencils, because you make mistakes. Everybody makes mistakes. Okay, now I go back and I look at this. 399 grams, 638. Which one's my answer? What one am I going to box and say this is my final answer? This one. Okay, that's my final answer because I know I can only make the least amount. So this is my answer to A. That's the amount of product I can make. Okay, now let's look at B. Okay, excess. Well, what did this tell me? This told me my iron is my limiting. Therefore, I know I have excess oxygen. Somebody ordered too much. Too much in the air around us. Who did that? Let's figure out how much extra oxygen we had. So let's go back. We have to figure out then how much did I use. So for every 5 moles of iron, how much oxygen really got used. And I know that I have 3 moles of oxygen. I need 3 moles of oxygen for every 4 moles of iron. Okay, and you know what? I'm going to leave it back there. Just realize I want to leave it in moles, and I'll show you why. It's because I gave it to you in moles. Let's just for a minute keep it at moles and do this right now to figure out. So from right now, how many moles did I actually use? I actually used 3.75 moles. And the reason I kept this was in moles is because I gave it to me in moles right here. If I had given this in grams, I would have gone ahead in grams. But the key things make these match up on these units. So what I can say now, okay, so I had 6 moles. I used up 3.75 moles. How much do I have left over? I have 2.25 moles of oxygen in excess. Okay, it did ask for grams. So you know what? Now is when I'm going to use the molar mass. Let me see if I can get this one right. I have moles on top, so guess what? I'm going to put moles on the bottom. I'm going to slow down, take a little bit of care in my work, and then what do I know? 32 grams. So what do I need to have? 2.25 times 32. So how much in excess do I have? 72 grams is excess. Okay, this is where I'm going to stop today. I know it's kind of overwhelming. I really want you to try 19 and 20. Those are ones we're going to start on Monday, and I will show you that alternate method. Then we're going to start when we work on these because you're watching this over the weekend. That means you have time to actually be trying these. So I want you to be trying these, and we know on Monday we're going to be working more on the worksheet, but there's really not that many on the worksheet. And this is where I know there's questions. There's going to be questions, and that's why work 19 and 20. Try. That's the key word. You've got to try and give some things so then you can come with questions of where you didn't understand. I will see you Monday. Click exit. No.